What's up guys, and welcome back to another video. In this video we are not talking about the fluffy animal or the song by designer, but instead we're going to dive into the Pandas library of Python, which I find to be one of the most useful libraries when you're doing anything data science related in Python. So this video will be a good standalone video if you've never done anything with Pandas, kind of going from zero to like fairly comfortable in one sitting. It also is a good video if you have some Python Pandas experience, but you're looking to try to figure out how to do something specific. If you're in that second case, look down in the comments and I'll pin a timeline of what we're doing in this video so you can find exactly what you're looking for quickly. So one question you might have as you watch this video is like, why Pandas? A lot of the stuff you'll see me doing, you probably could replicate in Excel, but there are specific benefits to using Pandas. And the first benefit is you have a lot more flexibility with Pandas and using Python in general. Like what you can do in Excel, I think is very limited compared to what you can do using the whole Python programming language. So like the flexibility that Python offers is reason one to use Pandas. And then the second reason, this is also a very important reason, is Pandas allows you to work with a lot larger data sets than Excel does. Excel really kind of struggles once you start loading in really large files. So the second reason of why Pandas is you can work with big data. If you're finding this video useful, don't forget to click that subscribe button because I'll be making a lot more tutorials building on this type of stuff in the future. Okay, to begin this video, you should already have Python 3 installed, and then you need to open up a terminal window and type in pip install pandas if you don't already have the library. As you can see, I already have it. Once you have the library, we can actually begin loading in data super quickly. So I just want to dive into the data right away, and we'll use that data to kind of learn everything we need to know regarding this library. So I have a link in the description to my GitHub page where I have a CSV of data that we're going to be using for this video. So go to my GitHub page, and then this data is going to be on Pokemon. I found this data on Kaggle. It's like a good open source machine learning website that you can kind of like do all sorts of challenges. And I thought it was perfect for an introductory video on Pandas. So you don't have to be a huge fan of Pokemon, but it's a great data set to get started. So click on the CSV version. That's kind of the most important one. As you can see, you can kind of get a feel for what's in this data. So we have all the different Pokemon and then all of their kind of stats. And we'll be doing all sorts of manipulations and doing all sorts of analysis on this data throughout the video. But I want you to click on raw. And then once you have the raw file, you can just save as. I called mine Pokemon data and I saved it as a CSV. CSV is important for loading it in properly. But you can name it whatever. So Pokemon data.csv. And one thing to note is wherever you're writing your code, you should save this data in the same exact directory, just so it's easy to load in these files. Okay, once you have the data saved locally, open up your favorite text editor. For the purposes of this video, I'm going to be using Jupyter Notebooks because I like using that for data science related stuff. But you can use Sublime Text, PyCharm, whatever you like to write your code in. And I'm going to just clear all of this that I have on the screen right now. Okay, so the first thing we're going to do is load data into Pandas. So we have this CSV, and you can open up the CSV and look, but exactly what you saw on this page. So this is what we're going to load into the Pandas library, and we're going to load it in what is called a DataFrame. It's not super important, everything about a data frame, but that's kind of what the object type is that Pandas allows you to manipulate everything with. Okay, so the first thing we need to do is type in import pandas to get the library. And usually what you'll see is it's kind of annoying to have to reference pandas every time you type anything in that uses it. So we usually import it as pandas as PD. So just do that. And then to quickly get our data loaded in, I'm going to just say Poke, meaning Pokemon, or maybe I can just call this like df for data frame equals PD. And then there's this really useful function called read CSV. and then you have to pass in the path to that CSV. And if you put the CSV in the same file or in the same location that you're writing your code, you can just do the name of the file .csv. And if I run this, it loaded it in, and you can't see that it loaded it in, but if I went ahead and did print df, you could see that all of that data is there in that df variable. And if you don't want to load in all of the data, you can use there's these two useful functions to look at just the top of the data and just the bottom. So I could do df.head, and then I could specify a number of rows. So I'm going to just say 3 for now. I think the default, if you didn't put that 3 in there, is 5. So you see I just now can see the top 3 rows, and it's a little bit easier to read my data using that. And I also could do, if I wanted to see the bottom 3 rows, I could do tail 3 and get, as you can see, the index is changed to the bottom, get those bottom rows. Okay, I'm going to just comment this out real quick. I also want to show you that if you don't have your data in a CSV format, that's fine. We can also very easily load in Excel files or tab separated files. So on that GitHub page, I also, just for the sake of practice, included this same exact file in TXT format, which is a tab separated format, as you can see, and the Excel format. So if you want to try this, or you have a set of data that you're trying to manipulate, you can also do load those files in. So I can do pd.read Excel. That's another built-in function to Pandas, and my Excel file was like Pokemon data.xlsx, I believe. Let me just check. Yeah, I don't know. Yeah, I think that's the extension. We'll get an error if not. And I'll comment this line out too. And I can do a print of df xlsx.head 3. As you can see, that same data is read in from that Excel file. And then the last thing we can try to do, and I'll move this just so it's a little bit cleaner. Move this down here, comment it out real quick. I can also load in that tab separated file. So this one's a little bit different. I can do pd.read CSV, Pokemon data.txt, and watch what happens when I run this. It's probably going to give me an error. Let's see. Oh, it didn't. Print df. Let's see what happens. I think it's going to, yeah, it loaded it all in as like this one single column. So the difference with this tab separated file, and just to remind you what this looks like, just instead of having commas that's separating the different columns, it's tabs. We need to, in our read CSV function, specify a delimiter that's actually separating them. In this case, it's a tab, which is specified by /T, I believe. I don't remember the differences between / and \. And yay, look at that. We have the columns in the way they were looking when we were just doing the CSV. Also note for this TSV, the tab separated file, you could change this delimiter to anything that was actually separating your column. So if, like, let's say for whatever reason you had 3 X's separating your columns, you would set delimiter equals XXX. All right, let's move on to the next thing, and that's going to be actually reading our data easily within the Pandas framework. So the first thing is reading the headers. So in our data, we have several headers, and we can figure out what those are by doing a print df.columns. So if we want the headers, we just do df.columns. As you can see, there's the Pokemon number, or Pokédex number, I think. I don't. It's been a little while since I've refreshed my Pokemon skills. The name of the Pokemon, the types, the 2 types, and all of the stats information, and whether or not they're legendary. So these are all the columns we can work with. And so I'll just not print that for now. Also, this Jupyter Notebook, I'll save this on the GitHub page once I'm finished with the video. So you can also look at this if you use Jupyter Notebooks, follow along with this if you just download it from the GitHub page or clone it. All right, so now that we know our columns, let's read a specific column. So to do that, we have our data frame still that we loaded up here, and I can do df dot, let's say I wanted to get the name of the Pokemon. So if I just did print df name and ran that, as you can see, I got all the Pokemon, and it does actually abbreviate it just so I'm not printing out like 800 different things. So that gets me that. And I could also specify that I only wanted like 0 to 5 probably by doing this. Yeah, so now I just get the top 5 names. One thing that's interesting, you could also do df.name like this. This doesn't really work for 2-word names, but you could also get the names like that. I usually just do it more in the using the brackets. And if you want to get multiple columns at the same time, you can change this just single word to a list of column names. So I'm inserting a list here and then separating it by commas. So name, say type 1, and let's say like HP. So we're getting 3 different columns, and they're not even all in order, so it's kind of nice. So there you can go. So if you want to look at specific things and not be cluttered with so much extra stuff, you can do that. Moving on to printing each row. Let's just comment this out real quick. Probably the easiest way to print out each row. So I'm going to just show you and remind you what's in our actual data set again. So let's print out the first 4 rows. And let's say we wanted to print out this first row, index of 1 row. So I guess this is actually the 0th row. So that has Ivysaur, Grass Poison, etc. in it. If we wanted just that row, we can use this iLoc function on the data frame, which stands for integer location. So if I passed in iLoc of 1, that will give me everything that was in that first row. I could also use this to get myself multiple rows. I could do 1 to 4, and that would get me all of these rows. So another way to get rows wherever you want in the data frame. And the same iLoc function can be used to grab a specific location. So let's say I wanted to, I'm going to just change this to 0 real quick. I wanted to get the Venusaur name here. So if we did the indexing of that, it's on the 2nd row, and it's the 0 first column if we're counting with numbers. So if I wanted to just get that specific position, we could do print df.iloc and then the 2nd row, and then do comma the actual position you want. So we want the first position, the first column. And as you see, that gives us Venusaur. Building upon this, one thing I often find myself trying to do is iterate through each row in my dataset as I'm reading it. And so to do that, what I would recommend you do, there's probably other ways, I'm sure there are, is do for index comma row in df.iterRows, iterate through rows. Probably the easiest way to just go row by row and just access any sort of data you might want. So I could do print index comma row and run that. As you can see, it didn't format it nicely for me, but it's going first row, then getting the data for the 2nd row, etc. And one thing that's pretty nice about this is I could, if I just wanted the name and the index for each row, I could iterate through and just get that information. I don't know, I find this pretty useful for all sorts of different tasks that I'm doing while working with my data. And then one additional function I want to get to right now, I'm going to go into this in more depth in a little bit, but in addition to having the iLoc, we also have df.loc, and this is used for, I guess, finding specific data in our data set that isn't just integer based, isn't just like the specific rows. It's based on more textual information, numerical information. So one thing that's really cool we can do with this is I can do df.loc, and then I can access only the rows that have df name, or let's say type 1 equal to, let's say, fire. So this should give us like Charizard, Charmander, Charizard, the middle one. So let's run it and hopefully this works. Oh, it outputs it pretty nice when I don't print it. Wow, I should have known this. Yeah, so as you can see, it's only giving me the type 1 that's equal to fire. And I could do the same thing if I only wanted to look at the grass Pokemon. As you can see, now we get Bulbasaur, Ivysaur, Venusaur, etc. And you can just keep doing this, and you can use multiple conditions. So this is super, super powerful to do all sorts of conditional statements. And I'm going to get into this, the more fancy, advanced stuff regarding this later on in the video. While we're on this topic, another useful thing we can do with our data frame is we can use this .describe method, which gives us like all the high level like mean, standard deviation type stats. Run that. So as you can see, some of these categories it's not super useful, like Pokédex number, we don't really care about the mean, but for like HP, attack, defense, special attack, etc., it's a pretty cool little method to use because you have all of these metrics. You can quickly just look at your data. Another useful thing we can do is if I just print the data frame again, we can do some sorting of the values. So let's say instead of going from first Pokédex downwards, we could do sort it by, let's say, alphabetical name. So I could do sort values, and then I have to pass in the column I want to sort. So if I sorted values by name, now I have it alphabetical. And if I wanted to make it the other way, I could do extending. So that's, and that equal to false. So now it's going to be descending, as you can see. You also can combine multiple columns in this. So let's say we're sorting by type 1, and then we wanted to have our second sort parameter be by HP. So this would give us all, like, I guess probably the bug Pokemon, because that would be the first alphabetical one. And then it would give us the lowest or highest HP from that. Let's see what happens. Yeah, as you can see, bug, and this is the lowest. So what we could do is also pass in ascending. And this time, because we have two columns, we need to specify true or false for both. Or we might be able to do this. Yeah, we can do this. But if you want to separate, if one's ascending, one's descending, we can do, see now I got it descending, but we got the farthest down type 1. So I can do something like this. So we want the first one to be ascending and the second one to be descending. So now type 1 will be going A through Z, and HP will go from high to low, as you can see. So sorting the values is very useful as well. Okay, now that we know how to read our data, let's actually start making some changes to it. So let's look at our data again. Okay, so looking at this data, one change that I think would be cool to make is we have all these stat categories. I think it would be pretty cool to add all of these stats together and create like a total category, which kind of potentially could help us rank which Pokemon are the best. So let's go ahead and do that. And one thing that's cool and I guess true about most things programming is there's multiple ways to do this. So we're adding a column that is the total of those stats. So one way we could do it is we just go ahead and access our data frame and then just call this new column total. And we can just reference it like this right now. And we will say that equals, this is probably the easiest way to read, but not the, I guess, fastest way to do it. But you could do df of HP plus df of attack. I'll probably speed this up when I'm actually editing this. Okay, so now how I defined this one was You have the data frame total is going to equal all of the other columns. Run that. I guess we don't see anything, but if I go ahead and do dataframe.head 5, as we can see over here on the right side, we have this new column named total, and I would say I recommend always when you do something like this, just making sure that you did it like actually is the total that you're trying to get. 49 plus 65 plus 65 plus 45, because you could easily see that this total is a valid number, but if you don't actually double check that it's the right number, you kind of run into a dangerous territory. And as we can see, perfect. 318 is exactly what we are looking for. So that's one way to do it. Another way we could go about doing this, and actually because I'm using a Jupyter notebook, what we might want to do first is drop some columns. So one thing about Jupyter notebooks is like if I run this again, even though I've commented it out, lost myself, it still has that data frame in memory. So even though this is commented out, it still has that data frame in memory. So it doesn't remove the total after I even comment this out. It just stays in memory. But so one thing we might want to do is drop a specific column. So if I wanted to go ahead and drop the total column and just show how to do it in another way, I could do dataframe.drop, and then I can specify the columns. And I'm going to specify total. I'm going to run that. Why did you not disappear? And so the reason this did not disappear is because it actually doesn't directly modify, it doesn't directly remove that column. I believe you have to just reset it to data frame. So I can go ahead and do this, and we should see this total column here on the right side, which my face is blocking. We'll see this disappear. Run that. Yay! So that was dropping a column. So now if I wanted to go ahead and do add a column in a different way, maybe a little bit more succinct of a way, I can go ahead and do df total. That stays the same. And then what I'm going to do this time is I'm going to use that iloc function that we learned. So integer location, I want all of the rows. So the first input is going to be the colon, which just means all rows, everything. And then the columns I actually want to add together will be HP through speed. So that will be, this is 0, 1, 2, 3, 4. So this will be the fourth column to the 5th, 6th, 7th, 8th, 9th, to the ninth column. And I'll run, and then there's a dot sum function you can use, and you want to specify, if you're adding horizontally, you want to specify axis equals 1. If you said axis equals 0, that would be adding vertically. Okay, and we have our totals again. And one thing you might have noticed, I don't know if you caught this, but because I have this 318 down here, I realized that this 273 is actually wrong. So that's why it's good to make that check. The error I made was that it shouldn't end at 9 if we want to include this speed. It actually has to go to the next one, because the end parameter in like lists and numpy, everything the end parameter in lists is exclusive. So 10th means the 10th column is the first one we don't include. So I rerun that. Now you see that the totals are actually correct as we did the math down here. The last change we'll make before we resave this as another CSV, the last change we'll make before we resave this as an updated CSV will be, let's say we didn't want this total column all the way over here on the right side. It makes a little bit more sense, I would say, to be either to the left of HP, sorry, I don't know what that was, or the right of speed. So we can do this in a few different ways, and the way I'm going to choose is probably not the most efficient, but it makes sense given what we've done already. So remember that we could grab specific columns like this. So if I wanted total, I wanted HP and like defense, let's say. And note, I can order these however I want. So if I wanted to reorder my columns and then save it afterwards, I could just do df equals whatever order I choose. And because it's a little bit annoying to type out all of these things, I'm going to get the columns as a list. To do that, I will do calls equal df, and you don't have to know what I'm typing works exactly. I'm looking at the documentation as I do this. And I recommend you guys do the same. Always look at the documentation. There's great stuff here. I can't get everything out here in this single video. I'm doing the best I can, but definitely check the documentation out. I'll link to that in the description. Okay, so I'm getting the columns, and instead of ordering it like this, I'm going to do ranges. So if I want these first 4 columns and then total and then the remaining columns, I could do something like this. Calls of 0 to 4, that'll get me the first 4 in the same order I wanted, plus calls of -1, that's just reverse indexing, getting the total here. I might be blocking that again, the total here. And then finally, the remaining stuff we need to add to, that will be 4, 2, 5, 6, 7, 8, 9, 10, 11, 12. And we can include 12 because that will be in the first one we actually don't include in the final data frame. So let's see what happens when we do that. We want to see this total go over here. No, what happened? Okay, so why did we get this error? Can only concatenate list, not string to list. So that's telling me something probably in here is messed up. And what I'm seeing is that because this is a single column, it's not going to be, it's just going to be a string. So I have to actually surround that in brackets to make it a list. And then I can go ahead and run this again. And we wanted to see the total switched over to the left side. And there we go. It is there. Cool. One comment I want to make, as I said before, this type of change doesn't actually really modify our data at all. It's just kind of a visual thing. So I didn't really care too much about how I went about and did it. But one thing I really want to note here is be careful when you're hard coding numbers in like this. If your data is changing and you have these hard coded numbers, it's very easy to screw things up. So as much as you can, I like just using actual names. So even calculating the total like this is a bit dangerous. So maybe instead of using 4 to 10, what thing you could potentially do is get the index of your start. So that would, when we were doing this, it was the index of HP, and then go to the index of speed. That would be one way to do it. It's a little bit safer, I would say. All right, now that we're done with all of this, let's move on to saving our new CSV. So just a reminder of what we have in our data frame. We have all of this information. And in the previous cells is where I actually defined the data frame, just as a reminder. This data frame is not coming out of midair. So I have this data frame. And now I want to save this updated, and let's start by saving it to a CSV. So just like we had the .read CSV, we also have a built-in function in Pandas called toCSV. So I could just call this something like modified.csv, and now it will take whatever's in this data frame and output it to a nice comma-separated values format. So because I got to this next cell, we know it did that. I can check my directory, and as you can see, there's this modified CSV. And I'll just open that up real quick just so you can see that all of the information is there. Load. Okay, so we see we have all the stuff we wanted and this total column there, which is cool. The one thing that is annoying about the current state of this, stop texting me, I'm making a video. Oh my God. Who has the nerve? Okay. Sorry about that. So the one thing that might be annoying is that you have all these indexes over here, and I don't really care to have those. So the quick fix to not save all these indexes with your data, you can if you want to, but you can go ahead and pass in the variable index equals false. Run that again, and then I reopen my modified CSV. You will see that that stuff is all gone. So yeah, now we just have the Pokédex as our farthest column to the left, which is perfect. You can also go ahead and there's also a built-in toExcel function. So I could, if I wanted to save this as a Excel, even though right now we're just working with the data frame, it's easy to output it to that format. So toExcel, we'll call this modified.xlsx, and we can also make the index false here. Run. And so that will now, we have these two modified. This is the actual Excel file. I could load that, but for the sake of time, I'm not going to. And then finally, the last way, we loaded in 3 formats. I might as well save 3 formats. So the last one is, what if we wanted to save that tab separated file? So we could do toCSV again, modified, I'm gonna just call this modified.txt, and index equals false. And then the one thing on this is there's no delimiter parameter for when we're doing toCSV, which is kind of annoying, but there is a separator parameter you can pass in. And look at the documentation if you need to remember this. I'm looking at the documentation as I speak. And so I can specify that I want to separate it with tabs instead of commas. That's going to happen by default. So I run that. And I will actually open this one up just so you can see. Modified here. And if I drag that in, you can see that all the data is there. No indexes on the left, and it's all separated by tabs. So that looks pretty good. All right, now that we've done all of that, let's move into some more advanced Pandas stuff, and we'll start out with some more advanced filtering of our data. So just a reminder, this is our data frame. So as the first example I showed before was that we could specify a specific type, for example, that we wanted. So if we did df.loc, and then we said df of type 1 equals, let's say grass, we're only going to get the rows that actually have grass as their type 1. So as you can see, all these type 1s are grass. In addition, we can do just more so than just one location condition, we can pass in multiple. So I can do something like df type 1 equals grass, and let's say we wanted df of type 2 to equal poison. So I can type it in like this, run it. Oh no, we got an error. So the thing you got to do here is we have to separate our conditions with parentheses for whatever reason. Not quite sure why that is. So here I have 2 conditions, separate them by parentheses. And as you can see, we only have grass and poison now. And one thing to note is usually we're typing out and like this, but inside of our Pandas data frame, when we're filtering, we just do the actual and sign. Let's say if we wanted type 1 equals grass or type 2 equals poison, then we could do the or sign like this. It's a little bit different than you're normally used to. It's just the convention of the Python Pandas library. And just look this up if you forget. So I run that. Now we should have 1 is poison. Either type 1 is grass or type 2 is poison. As you can see, this is a bug type. This is poison. So it was able to separate those 2 conditions by an or instead of an and. And we don't have to just use text conditions. I could also add in, let's say we wanted type 1 is equal to grass, type 2 is equal to poison, and let's say we wanted the HP to be a fairly high value. So just looking at these, I feel like 70 is a good cutoff value. So HP has to be greater than 70. I can also specify conditions like this. And I run that. Now you see we only have 5 rows that it actually filters out. And you could go ahead if you wanted to. There's a couple different things you can do with this. So first, if you, let's say you wanted to make a new data frame that was just the filter data, I could just do something like new df equals this. And now if I print out new df, we get just those 5 rows, but I could go ahead and just print out df and we still will have everything. Also worth mentioning real quick, I can easily save this new data frame as a new CSV, kind of to checkpoint my work. And maybe if I wanted to do this on many different filters, kind of have this more specific CSV files that I could dive in and look at in more depth. So I could call this something like filtered.csv. If I ran this, you'd see in here that I have this filtered and it contains the data that I just grabbed out. One thing to note when you are filtering your data and you shrink down the data size is when you print out that data frame, so I'll comment this out real quick and just print out new df. As you can see, one thing that's weird is this is the index here. So it goes 2, 3, 50, 77, 652. Even though we filtered out our data, the old index stayed there, and that can get annoying if you're trying to do some additional processing with this new data frame. So if you want to reset your index, you can go new df dot reset index, and you can start off by just setting new df equal to new df dot reset index. Now if I print out new df, you see that we have 0, 1, 2, 3, 4. And by default, it saves that old index there as a new column. If you don't want that to happen, we can modify it further. We can do drop equals true. So this will get rid of the old indices. As you can see, now we don't have that. Then the last thing is, if you don't want to have to reset it to a new data frame, you can actually do this in place as well, which just probably conserves a little bit of memory. And if I run this, I don't even set it to a new variable. It just will change the values within the given new df. And as you can see, we got the new indexes for our filtered out data. So that's something useful to be aware of, because if you're running through your new data frame like row by row and you're trying to get a specific spot, even though it's like the 4th row that you see, it might be, you might need to index like, you know, the 71st position, and that would get really annoying. So resetting indexes is helpful in this case. In addition to, I guess, equals conditions, greater than, less than, etc., not equals, we also have other types of conditions we can use. Basically anything you can think of. So one thing that I see that is kind of annoying me with this data is if you look in here, maybe this is just because I'm like a little bit outdated on my Pokemon knowledge, but I'm seeing these like mega versions of Pokemon, and I'm not quite sure what that really means. So let's say I wanted to filter out all of the names that contained mega. And it's tough to do with equals signs, you know, because contain is not quite equal to, because we want to allow a lot of different things through. So I could not allow the name to include mega by doing the following. So I'm going to delete the stuff that's inside of here, or maybe I'll just comment it out so you can still see it. But I'm going to do df.loc, and then I'm going to pass in df name. And then I need to get the string parameter of the name. This is something you should just kind of, I guess, remember about the contains function. String, and then dot contains mega. So if I run this, you'll see that all of these ones are just the columns that include the word mega. And then if we want to get the reverse of this, this is another good symbol to remember because it's not quite what you would think it would be. But within the loc function, if we want to do not, instead of maybe thinking it would be the exclamation point, it's actually this squiggly line. So if I run this, now we drop all of those ones that had the mega. So as you can see, there's no megas anymore in our data. So that's pretty useful. And taking this even a step farther, This contains function I find to be very, very powerful because in addition to just doing exact words, we can also pass in regex expressions and do all sorts of like complicated filtering with this. So let's say, as a first example, let's say we wanted to see if the string, wanted a simple way to get if the type 1 was either grass or fire. So to do that, I would first have to just import regular expressions. And I would recommend looking into regular expressions if you don't know what they are. Super, super powerful in filtering data based on certain textual patterns. So I can do regex equals true. And right now I'm trying to find if type 1 is equal to fire or let's say grass. So in the regex expression, this means or. So I want it to either match fire or grass. Run that. Shoot, it did not give me anything. And the reason it didn't give me anything is because the capitalization was off. So this is going to be another good point. So see, that did work. Type 1 grass, type 1 fire, etc. But a probably nicer way to do this, because you might have all sorts of funky capitalization, is I could go ahead and change it back to this way. But there's a flag that you can use. So I can say flags equals re.I, and that's going to be ignore case. So I run that again. And as you can see, grass and fire is grabbed, even though I specified it without the capital letters. One more example. Let's say I wanted to get all Pokemon names that started with a PI. So probably the first example you might think of is Pikachu, but you also would have like Pidgeotto and probably a bunch of new ones that I don't know. So if I wanted to just get data in the name category that started with PI, I could use regexes to do the following. I could do PI and then specify that I need it to start with PI, but the next set of letters can be A through Z, and let's say like this star means 1 or more. And yeah, this is all just regex information. If it seems super, super foreign to you, look into regexes. And if I do this, we didn't get anything. What happened? Oh, it's because I said type 1. So if I actually change this to name, run it, as you can see, oh, we got Caterpie. So I did something messed up with my regex. But as you can see, there's all these PI names in it. And if I wanted to eliminate this from happening, the PI letter to be in the middle, I can specify start of line with this caret. Run that. Now we got only our names that begin with a PI. And you might find this, there's many different use cases where you might find something like this useful to do to filter out your data in a kind of complex manner. Building off the filtering we did in the last examples, we can actually change our data frame based on the conditions that we filter out by. So let's imagine I wanted to, I didn't like the name fire for type 1. I thought that, it would be better if it was named like flamer. If you have our fire type, you're actually a flamer. So let's make that change. And I know this is going against Pokemon tradition, but just to show you, df.loc, and we want to have df of type 1 equal fire. And if that is the case, well, I can do, if I specify with a comma, I can specify a parameter. So I'm going to say type 1. So this is the column I want. And I can do equals like flamer. It looks like something is off. Why does it look like something is off? Oh, it's because I have an extra bracket there. Now it should be good. Run that. Don't see anything, but if I do df, oh shoot. You can see that now type 1 is flamer as opposed to fire. If I wanted to change it back, I could go fire, and this is flamer. Now I have fire again. We also can do like specify this to be some different different column. It doesn't have to be the same column we're editing. So maybe you decided that legendary Pokemon are all Pokemon that are of type fire, and you could make this true in that case. And as you can see, now all of the fire Pokemon are legendary, which obviously isn't true, but it's kind of cool that we can use one condition to set the parameter of another column. And I'm kind of screwed up this data frame in general now because I did that. So what I could do is use kind of my checkpoint. That was the modified CSV. So I'm going to just say CSV equals pd.read CSV modified.csv. Now I'm just kind of loading my checkpoint that I had a while back. df. So now I fixed up the false, the legendary, by just reloading my data frame. You can also change multiple parameters at a time. So I'm going to just do this as a demonstration, but imagine we wanted to say like something like if the total was greater than 500, it's pretty damn good Pokemon. I'm just going to say these changes that I'm going to make right here don't really matter, but just to show you that certain conditions can be modified. Multiple conditions can be modified at a single time. So if I want to modify multiple columns at a single time, I can pass in a list. And if I set like this to be test value, don't worry about this, that's why I'm saying test value. So if the total is greater than 500, these two columns should, instead of having their normal values, should have test value. Let's see if that's true. Oh, and I just need to print out data frame. As you can see, this total is greater than 500. This is greater than 500. This is greater than 500. All of them modified as we wanted. And another neat thing to know is that you can modify them individually as well. So this could be test value, or like, we'll say that this is test 1, and this is test 2. So now we are specifying what generation becomes and what legendary becomes if this specific condition is met. As you can see, that updated appropriately. Comment all of this out real quick and just reload the data frame as it was initially. Okay, so that's just, I'm just resetting the changes because I don't want them to stay. But showing you that you can do these things and they become super, super useful. All right, we're gonna end this video by doing something that I find very useful, and that's using the Groupby function to help you do some aggregate statistics. So let's start by loading in that checkpointed CSV we kind of created. So modified.csv is what I'm gonna load in. And just a reminder, this is what it's looking like. All right, so with this Groupby function, we can start doing some really kind of cool analysis on things. So for example, one thing I could do is if I wanted to see like the average HP and attack of all the Pokemon grouped by which type they are. So like maybe trying to figure out like, oh, are specific types like have better skills? So maybe a rock Pokemon would have like high defense. I think there's a rock Pokemon. Steel Pokemon would have high defense. You know, maybe a poison Pokemon would have high attack. So we can start seeing that as a kind of holistic measure by using this Groupby function. So I can go df.groupby, and let's say I wanted to group by type 1. And we're going to look for the averages of all the type 1 Pokemon. So I can run that. And here we get all of the stats broken down by their mean, sorted by what type 1 is. So if I look at a bug, it has like an average attack of 70. And to make this even more useful, I can use the sort function we learned. So sort values, and we'll sort on, let's say, defense. And I'm gonna make this ascending equals false so I can see the highest defense type 1. And as I mentioned before, we did kind of see what I was expecting to see, that if we took the average of all steel Pokemon, they have the highest defense, which is kind of cool. It's cool to see that. We could also, instead of doing defense, we could look at what is, of all Pokemon that are have a type 1 that's the same, who has the highest attack? And I was thinking maybe it would be poison, but I'm not positive. Okay, so we got, this does make sense. We got Dragon with the highest average attack, and a lot of the Dragon Pokemon are legendary, so there's no surprise there that they're super powerful, and like, holy crap, like a dragon would be very scary. Fighting, obviously that makes sense that they should have good attack. Let's see who has the best HP. This might, Dragon also has the best HP. But it's kind of cool that we can group by type 1 and see all these like useful stats about them just on that group. It's a useful little analysis tool. And I could additionally do something like .sum. So I can use the three that come to me in my mind immediately. There might be others that you can aggregate statistics you can do with group by, but sum, or mean, sum, and count. So if I did this and summed everything, here I have like all of the HPs added up. And you know, you got to be thinking about why you're doing something when you're doing anything data science related. In this case, it doesn't really make sense for me to sum up these properties because like I could sum up and see that one's like way higher than another, but because you don't know how many type 1s are bug or type 1s are dark, etc., this aggregate sum doesn't make sense in this context, but you can do it. Then you also have count. So if I run this, we have all of the counts of the different amount of Pokemon that are type 1. So 69 are bug, 31 are dark, 32 are dragon type 1. And if you want to clean this up a little bit, like you have a lot of the same values everywhere. Basically, it's anytime it's a non-zero, non-false number, or I think just, yeah, anytime the row is filled in. So like the reason this is 52 right here is because the type 2 was just blank, so it didn't count those counts. So if you wanted to just have like a clean, this is the count, you could add df equals, or df of count equals 1. So basically what I'm doing is I'm filling in a column added to the data frame, and I'll show you this. That's just a 1 for every row. As you can see on the right side where my face is normally blocking, there's this 1 here. So now what I could do is, I could do that same group by count, right? Oh shoot, it's commented out. And I get all of this back. But if I want to just make my life easier, I can do just get the count column. And now I have this useful little set where there's 69 bug, 31 dark, 32 dragon, etc. So it's a little bit easier to read now. And now that I have it in an easier to read format, I could also group by multiple parameters at the same time. So I could do type 1 and type 2. So it's looking at all of the subsets. So of type 1 bug, 2 have a type 2 of electric, 2 have a type 2 of fighting, etc. I can do all sorts of counts. And this gets really useful if you're working with a really, really massive data set. And I'll get into that quickly. I don't know if I'll go through the full example, but imagine you had a really, really big data set and you couldn't even load it all into one data frame. This group by and like count and sum is super useful because you can take your data frame and kind of squish it. So if you're like tracking some number of like how many times an event occurs in your data frame, you can use this group by and like count things and then kind of squeeze your data frame, make it smaller based on this group by function, if that made any sense. So I'm not going to show you guys exactly, just because we've been working with a data set that's not that small. I don't really feel like bringing in a new data set right at the end. But imagine you're working with a data set, a file that's on the order of like 20 gigabytes. It's pretty dang big, and you don't really know how to best process it. One thing that's really useful about the Python Pandas library is it allows you to read in like a file like that. You can read it in chunks at a time. So instead of reading it in all 20 gigabytes, because unless you have a very, very powerful machine, you're not going to be able to load all of that into memory. You can load it in, let's say, 100 megabytes at a time. And so normally when we are reading the CSV, we would do like pd.read CSV. Modify.csv is the file I'm using right now. And that would load everything in. So instead of doing that, what we can do is we can pass in this chunk size parameter. So I'm going to just say for now, chunk size equals 5, just for the example. And that means 5 rows are being passed in at a time. So if I did for df in pd.read CSV, that means that my df right here would be 5 rows of my total dataset modified.csv. And because this is rows and you would rather think a bit in like terms of actual memory size, you can do a little bit of math with the rows to figure out how much memory that will actually be taking. If you think every row is probably like maybe 10 or 20 bytes, shouldn't be much more than that, you can do some math on how big this is. And if you run into an error, you can always, like that you don't have enough memory, you can always shrink this chunk size. So if we were working with a really big data set, we might set our chunk size to 100,000 rows at a time, which is a lot of rows, but nowhere near how much that full 20 gigabytes would be. But for example, we're just loading in 5 rows at a time, and I can show you that that is happening. So temp or like chunk data frame and then the data frame, just to see how it's working. So we have the first data frame, and as you can see, it's 5 rows. Second data frame, another next 5 rows. Third data frame, the third set of 5 rows, etc. So this loaded in the data frame, but in chunks of 5. So what's useful with like the aggregate stuff we were just going through is you could also like define some new data frame equals, let's say, pd.dataframe, and you can give it like the same columns as you had in your original data frame. This would just create a new data frame that's empty with the same column names. Basically what you can do is you could, let's say, like define df.groupby of type 1, let's say, and get like the count of that stored in results. And what you can do here is with that new data frame you defined, you could do something like, you can use the concat function of Pandas, which just appends 2 data frames together, and you could do something like new data frame equals pd.concat of the new data frame and results. So basically what this would do is always take your new data frame as you go through chunks, append on results, and store it back to new data frame. So as you did this, as you did more iterations, you'd be building this new data frame of all the information in your original really, really large data set. But because each chunk you're like aggregating, doing some sort of group by and count, you're shrinking that data size down so that this final new data frame has the meaning that comes out of that big original data frame, but it's a lot smaller, and you can actually do more analysis now on this shrunken down size new data frame. If that, hopefully that makes sense. If you need me to clarify this, just leave me a comment down below, and I'll try to clear things up regarding that. All right, that's all I'm gonna do in this video. Hopefully you have control, you kind of feel like you have control of the Pandas library now. If you felt like you learned something, make sure to hit that subscribe button. It would mean a lot to me. I'm gonna build off of this video in future videos, such as like plotting stuff in our data frames, and kind of doing some advanced stuff using like regular expressions. I don't know if it'll be tailored specifically at pandas, but a lot of useful information that you can take your Pandas skills and build off of. So subscribe for all of that. If you have any questions about anything I covered in the video, leave a comment down below and I'll try to help you out and clarify. And also, if there's any like additional features you would love to see in Pandas that I missed, leave a comment down below what that is, and maybe I'll make a follow-up part 2 to this video. All right, that's all I got. Thank you guys again for watching, and peace out.